to physics problems one by one.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So we talked about flat surface, body on the flat surface. We talked about body accelerating up and down when lying on the flat surface. We talked about the row between two bodies. We talked about the pulley and two bodies. Now let's add incline to the mix. Still no friction, but we have an incline. And we have alpha. And we have the body, the point mass. And they ask us about acceleration. And I do several installations of this. So the first is this. The first force is mg in gravity, as always. This is with whom this body is interacting with Earth. And let me draw it more horizontally, right? So this is a horizon, and this is alpha. And the next force is whom this body is interacting with incline. And there is no friction, and that's very important. At the moment they say no friction, there is only normal reaction. Normal, which means perpendicular to this incline. So this n is perpendicular, and we have mg. And let me do it a little bit more proportional. Let's do it like this. And that's all. And we have to write and this is second law of motion. The sum of all forces equals ma. And from that we have the sum of all forces. The first force is mg, and the second force is n, and this is ma. And the next step, of course, we solve in projections. And there are two typical ways, two coordinate systems, but let's first do with this coordinate system, y and x. And the next installation we will be dealing with different coordinate system, which will be x and y. But right now y and x, y directed perpendicular, x along the surface, makes sense. So projection of x, mg projects on x. So we have to draw a triangle. We have to make a projection. This is mg vertical, and this projects here, and this angle is alpha. Because this and this and this angle, they have both sides perpendicular to each other. This is perpendicular to that, and this is perpendicular to that. So that means it's the same angle. And so we have a triangle, we have a hypotenuse, and we immediately see that this is mg multiplied by sine alpha. And likewise, we have this projection, and this projection on this axis is mg cosine alpha. And that's all that takes. That's the only stumbling point here as far as I can see. So now we take mg and project it on x. And as I said, this is mg sine alpha. And as you see, mg sine alpha is directed along this line in this direction, so it's positive. Projection of n on this axis is 0. That's the magic of our coordinate system, because we make this perpendicular to the surface, and acceleration, body goes with this acceleration in this direction, so it's ma. It's unknown, but everything that's unknown we send down the same. We think it's positive, and if the answer will tell us negative, then we will know that we have to reverse direction. So this is the first equation, and along y-axis, we have mg, and as I said, this is mg cosine alpha, and it's directed negative, so it would be minus mg cosine alpha, plus n is positive and it's full force, it's only one projection, and a is equal 0. And we have two equations, and let me draw this picture out of the way, because I will be probably using it. So this is mg, this is alpha, this is mg sine alpha, and this projection is mg cosine alpha. And we have then two equations, and what is unknown? N is unknown, of course, and a is unknown, and it's very easy to solve. From the bottom one, we immediately have that n equal mg cosine alpha, so we know n, and from the top, mg, m is gone, a is equal g sine alpha, that's what they ask us. And let's look on this and see if that makes any sense. Let's imagine that alpha is 90 degrees, like 89, right? Let's say it's 90. Then this would be this picture, and the body will be simply falling down with mg. Our coordinate system would be like this, y and x, because it will be turning, and we will have mg equal ma and a equal g, and this would be our extreme case. Now let's plug alpha equal 90 degrees sine 90 degrees equal 1, and we have a equal g, so it makes sense. So if this is vertical incline, it's free falling with its inclined to the side, there is no friction, nothing, n is also disappears because cosine alpha, cos of 90 degrees is 0. And so, and if you don't know this, visit my math pre-request playlist about trigonometry and alphas and sine and cosine. So basically that makes sense. And if we have situation when alpha is very small, then sine alpha is very small, alpha equals 0. If alpha equals 0, sine alpha, sine 0 equals 0. And this is just a body standing like this. This is y, and this is x, and my client becomes horizontal, and this is mg, and this is n, and they are compensating each other. Cosine 0 is equal 1, and so this becomes n equal mg. Everything is balanced, no acceleration. So the results that we obtained make some sense. And basically that's it for this installation. And next installation, what I will do, I will deal with the same problem but in a different coordinate system, and we should receive the same result but in different system. But wait for this. Subscribe, and when I will publish this, you will have this video. Thank you.